Alright guys, welcome to our review test study guide. I'll be going through the even problems as usual. So for this one, for numbers 2, I think 4 and 6, we are graphing linear functions. You can look at your I believe it's 1.3 and 1.4 notes to help you out with that if you need a little reminder on how to do it. So let's go ahead and start with this one here. And the first thing is that we need to get that y by itself because we need it to be in something called slope-intercept form. I can't combine the 16 and the x, so I'll just put them next to each other. And I'm going to divide by the -4 here. The negatives cancel, and I've got x over 4, and the negatives cancel here, and I've got, therefore, a positive. 16 divided by 4 is 4. And I'll still rewrite this even a little bit more, because you can imagine there being a 1 there. I'm going to write that as a 1/4 x plus 4. Okay, so this is what we call slope-intercept form, and we call it that because the number that's here is our y-intercept. So I'm going to put a dot at 4 on the y-axis. And then my slope is 1/4. So we go up 1 and right 4. So starting from that y-intercept, I'm going to go up 1 from here and right 4. And connect the dots. And that's how you graph a line. Number 4, this is a funny kind of a line. Whenever you have x equals a number, it's going to just end up being a vertical line. So on the graph, we just go over to where x equals 4 and we draw a vertical line. And that's it. For number 6, y equals a number. For those kinds, we graph horizontal lines. And so we're going to go up to where y equals 4, and we'll just draw a horizontal line. And that's it. All right, for number 8, I would have you look back at your 2.1 notes. We're going to be solving the system equations using substitution. A system of equations is when you have two equations and you want to find out what is the x and y value that works for both equations. We're going to be using the substitution method because we have this here that says y equals. It can also work if you have something that says x equals. The way that we do this is we start off by identifying the y equals or x equals, circling what that variable is equal to, and then plugging it into the other equation for that same variable. So I'm going to replace y with what y equals. So instead of 4y minus x, I'm going to have 4 times 2x plus 4. After you do that, you're just going to go ahead and use your Algebra 1 skills to solve the equation. I'm going to start with some distribution there. Combining like terms is next. Then we have a two-step equation to solve. After dividing by 7, I find out that x is equal to -4. And to find the y variable, we just go back to the original equation here, and we replace the x value with the answer that we just got. Turns out y is also equal to -4, and there is my answer set. Okay. So once again, that's in your 2.1 notes if you want to have a reference for your test. All right, here's another system of equations, but this time we're going to use a different method than we did on number 8, and that's the method of elimination. Elimination is a method for solving a system of equations that works well when your x values, your y values, and the constants line up pretty nicely. So That's what we'll go with here. So the first thing you're going to do is you want to pick a variable that you would like to cancel out. I'll go ahead and cancel out the x's. Okay. What we're going to do is we're going to take the coefficients of these x's next, the 1 and the 5, and we're going to reverse them. I'll put a 1 down here and a 5 on the top, and you distribute that into the parentheses for both equations. Now, since I'm multiplying the bottom by 1, the bottom equation is not going to be changing at all. So that's step 1, if you will. And by the way, if you're looking for help for this, this would be in your 2.2 notes. There are some steps and other examples lined out there for you. We're going to go ahead and multiply one of the equations next by a negative. I'll go ahead and multiply the bottom by a -1. And all that's going to do is change all of its signs. So the top equation is going to stay the same. And the bottom will have all opposites now from what it had originally. And now we're ready to move on to the next step, which is to combine downwards. So we'll combine these, and they cancel. We'll combine these, and I'll get -8y. We'll combine these, and we'll get 16. And from there, we just solve what's left. And I get -2 as an answer. And once again, we have to find the x value also. And for that, you're just going to pick one of the equations. It doesn't really matter which one you pick. And you're going to replace the y value in this case with the answer that we got, which is -2. And then from there, you just solve. Now, this is kind of a strange situation. Oops, it's supposed to be 4. Because it turns out I got x equals -2. And I noticed that happened on the last one, too. They both had the same answer. Please don't think that always happens. That does not always happen. It just was an interesting coincidence on these past 2 problems. They do not always come out to be the same like that, but there you have it. All right, let's go ahead and take a look at number 12. This one says use the graph to determine the solution to the system of equations. So this is another way of solving a system. It's by graphing. So if you graph both lines, the solution is basically where they cross. So in this case, they are crossing at the point x equals 1 and y equals 2, and there's the answer. So those ones are pretty nice, quick, and easy. The one that comes before this is number 11. That one, this system of equations has no solution. It just wouldn't work out. Okay. Now, the same thing can happen whenever you're trying to solve an equation. If you end up with something like this, like 5 equals 2, well, that's not true, and that means there's no solution. Okay. So that can happen as well when you're solving the equations, but there's that. So that's system of equations, and if you want more examples of systems of equations with graphing, this one you can find in your 2.1 notes. Once again, it's with the substitution stuff that we did. All right, moving on. So it says evaluate each function for the given value. So they give me a function and they say find f of 2. In this case, what this means is that we are going to plug 2 in for x. Okay, so I'm going to take my function here, f of x is equal to -3x minus 2, and I'm going to replace the x's with 2. And there's my answer. F of 2 is equal to -8. You can find more examples of this kind of stuff in your 3.1 notes. Okay, we're going to look at a similar one next, but it is a little bit different. This is also in your 3.1 notes if you wanted to see how to do it. They give us a function, and this one they say find x if f of x is equal to -1. So whenever it's worded that way, what they're asking us to do is they're asking us to replace not x, but f of x with -1 and solve for x. And so that's what that means we do there. All right, so I'm going to take my function and I'm going to replace the entire symbol here, f of x, with -1. And from there we just solve for x. And in this case I do that by division, and I end up with 1/4 positive because the negatives cancel. All right, so for our next problem, you can see more examples of this kind of stuff in your 3.2 notes. All right, but what they're basically doing is they give me two functions, f and g, and they want me to multiply those functions together. So we want to do f times g. Now the f function is 2x plus 2, and the g function is x squared plus 4. Now to multiply these, we can use the stuff that we've learned in Unit 4. I believe it was 4.2 notes if you want to see more examples of how to multiply, but that should be pretty fresh in your heads. We just took a test on that recently. But basically, you're just going to use a box method here. So we have 2x plus 2 and x squared plus 4. And then we just fill in our box. So 2x times x squared is 2x cubed. 2x times 4 is 8x. 2 times x squared is 2x squared, and then 2 times 4 is 8. I don't see any like terms in my box, so I'll just take the answers out now and put them in descending order from the highest term to the lowest powered term, and that would be my final answer there. All right, now number 20 is pretty much identical to the last problem I did. So instead of going over that, I think I'll back up and I'll do number 19. You can do the same if you want. You can do 19 instead of 20. So on this one, it's pretty similar though. We have two functions, f and g, and we want to multiply the f function by 3, and we want to multiply the g function by 3, and then finally we want to subtract those two things. So here we go. We have 3 times the f function minus 3 times the g function. The f function is -x plus 1, and the g function is x cubed plus 3x squared plus 2x. So to simplify this, we're going to start with just doing some distribution. In the second set, I'm distributing a -3. And then finally, we'll just combine our like terms. I have -3x can be combined with -6x to make -9x. The 3 doesn't have anything to combine with. The -3x cubed doesn't have anything to combine with, and neither does the 9x squared. So not very many like terms there. But we should put this in descending order, starting with the highest power, working our way down to the lowest power term. And there you go. All right, so number 22 is asking us to describe the transformations necessary to transform the graph of f into g. So we have the graph of f, and g is f function, but with some transformations added on it. So I'll highlight a few of these, but before we begin, let me bring up a piece of notes that I attached to this assignment that would be helpful to you. You can find this information in our Unit 3 notes, but it's spanned out over quite a bit of content. We talked about all this stuff starting in 3.3 all the way up to 3.6, and it's all about transformations. So this would be a nice little something to have written out or pre-printed to bring with you to our test for this review. if you don't have it already memorized. But this just basically tells you everything that all these different pieces do to transform your function. So I'm going to go through this, but if you don't want to listen to me, you can fast forward through this part if you want to. The A does a couple things. First of all, if it's negative, then it flips your graph upside down, which the way it's going to be worded on the test is it reflects it across the x-axis. Another thing, if the absolute value of that number, meaning ignore the sign, but just the absolute value, if it's greater than 1, then that stretches your function vertically up and down. It makes it longer or taller, if you will. And if the a value is less than 1, then it shortens it. It makes it shorter vertically. Now B does a lot of the same things that A does. The difference between these two is visually you can see that the A is outside the parentheses and B is inside the parentheses. It's right next to the X variable in that case. So for the B, it also does reflections and stretches and compressions, but differently. It does it horizontally instead of vertically. So if B is negative, then that's going to reflect your object across the y-axis instead of the x-axis. In other words, it flips it sideways, like spins it around that way. If B is less than 1, then that's a horizontal stretch, and if it's greater than 1, it's a horizontal compression. Okay. For this part here, the H can be subtracted from the X or added to the X. If it's being subtracted, it moves your graph to the right. If it's being added, then your graph will be moved to the left. And then finally we have the K. If the K is being added, that means it moves your graph up. If it's being subtracted, that means your graph is getting shifted downwards. So this will be a nice little reference sheet for you if you want to use it on our test that's coming up. So let's come back to this now. So here's the original function here, f, and g has a few transformations on it. First of all, I want you guys to notice that this is my b value. This is my h value, and this is my k value. So the first thing you want to do is make sure you recognize what letters these are. Next, you want to identify the transformations. So like this negative does something. The fact that this is a 3 does something. The fact that we are adding 2 for the h does something. And the fact that we're subtracting 1 does something as well. Okay, so let's go ahead and see what we have to deal with here. First of all, for the negative, when b is negative, that causes us to have a reflection across the y-axis. Next, we have the 3. Since the absolute value of 3 is greater than 0, that gives us a horizontal compression. Next, since I'm adding the h, our graph will be translated left. And then finally, since we have a -1 here, we'll also be translating down. So there's 4 transformations. Now just to kind of illustrate what that means, you know, the graph of f would look like this. Okay, that's what a square root function looks like. You don't have to know that, but I'm just using this for teaching purposes. But apparently, this g function, which I'm going to trace here in blue, this g function is going to have a few transformations on it. First of all, it's going to get flipped upside down. So what would that look like? Let me rewrite it here. So it gets flipped upside down across, or actually it gets flipped sideways across the y-axis. So it's going to cause it to go this way. Next, it's going to have a horizontal compression, which means that it's going to get shorter sideways. So it's going to be a little bit less lengthy going sideways. Next, it's going to get translated to the left. So it's going to be moved over a little bit. And then finally, it's going to be translated down, which means it would probably end up over here. So my final result would look something like this. It would be going the opposite direction. It would be a little bit shorter. It would be moved to the left and down compared to the f function. Okay, so that's all those transformations. There's quite a few things going on there. Here's another one. For this one, notice this -1 here. That's outside the parentheses, so that makes it an a value. This is my h value, and this is my k value. Okay, so the negative is going to do something, and the +2 is going to do something, and the +3 is going to do something. Notice I didn't highlight the 1 because if a is greater than or equal to 1, then it's either a stretch or a compression. But in this case, since it equals 1, it doesn't do anything like that. So the only thing that really matters there is the fact that it's negative. And what that negative does for the a is it causes us to reflect across the x-axis. In other words, it flips it upside down. Okay, next we have the +2. That means our graph is going to translate left 2 spaces. And then finally for the +3 with the k, that means we're going to translate up. Okay, so once again, I'll draw a picture for you. So the graph of f of x is x squared, and that looks like what we call a parabola. You probably remember that from Algebra 1. But we want to graph this new function here, g. So I'm going to trace this f function here in purple real quick. And apparently what we're going to do is we're going to be flipping it upside down. So that's going to cause g is going to be upside down when compared to f. Another thing that's going to happen is it's going to translate to the left. So my graph is going to be moved to the left a little bit, as well as be upside down, thanks to the translation to the left. Finally, we're going to translate it up. And so now it will look like this. And that's basically it. So G would look like the pink line here, F would look like the black line. All right, so for this next set, same thing, transformations, just a different type of question. I give you a function f of x, and then I give you a series of other functions like g, h, and I, and each of these other functions are transformations of f, and we have to find out which graph goes with which transformation. All right, so for number 26 is where I'll pick up. I see that there's a 2 here in front of the f. That will create a transformation, and also a +1. So let's go ahead and identify what those transformations are. So first of all, that 2 is an a value. A values, if they're negative, they can cause your graph to flip upside down, but my a is not negative. But what is significant about this is that that number, if you take the absolute value of it, it is greater than 1. And so what we will have there is a vertical stretch. So in other words, I will have a graph that looks kind of the same, but it's just that it's going to be a little bit longer, if you will. It'll be taller, it'll be higher. Okay. Another transformation that we have here is the +1. That's the h value. And when h is a positive, that means we're going to be translating it to the left. And specifically, since it's a 1, we'll be moving it 1 space to the left. So if I were to take this little pink thing here, if it'll let me grab it, I can slide it over. There we go, I slid it over a little bit. So as you guys can see, it's taller, and it's been shifted over a little bit to the left. So we're looking for a graph that would look something like this pink graph here that I just created, and that would be option C. So you guys can see it's taller and it's been shifted to the left, and so that would be option C for number 26. Go ahead and take a look at number 28 next. For number 28, I see two transformations. I see a negative here in the front, and I see a -2 here. As for the negative, that's the A value. When your A is negative, that means it's going to reflect across the x-axis. But basically what that means is your graph gets flipped upside down. So it would basically end up looking something like this. Okay. Another thing that I see is going on with it here is we have this -2. It's outside the parentheses, and that would be a k value then. And since it's negative, we're going to be translating this down. And since it's 2, we're going to be translating it down 2 spaces. So I should be able to take this little green line here and just shift it down 2 spaces. And so it should look something like that. So we're looking for a graph that's upside down and downwards a little bit more. So let's see if we can find that one. Oh, it's right here. It's option D, I can see. Okay. And that is another type of transformation question you guys can expect to see on our review test. But other than that, that's it. So hopefully that was helpful, and we'll see you guys in class. Have a good one.